Welcome back. Today is part 2 of Laws of Sines, so we're just going to be working some different examples today. Alright, so we have our first problem. We're going to be solving triangle ABC. If we know the measure of angle A is 33, the measure of angle, I apologize there, I forgot to finish that. This is angle B. Angle B equals 47, so I'm just going to write that up above. And let's see, B, lowercase b, so that would be side B equals 14. So we're going to round angle measures to the nearest degree and side measures to the nearest tenth. Okay? Alright, so if we draw this triangle, remember you don't necessarily have to draw a triangle, but just to review, so if this is angle A, scoot over just a little bit. So if this is angle A here, that means this is side A. Side A is opposite of angle A. So if this is angle B, then this would be side B. It's the side opposite of the angle. So then if this is angle C, then this would be side C because it is the side opposite. Okay? Alright, so then from here, we're actually going to be finding all of the missing pieces. So I'm going to go ahead and label the pieces I know. So angle A is 33 degrees. Angle B is 47 degrees. And then side B is 14. So I'm going to be finding the other pieces to this triangle. Alright? So we're actually going to start out with the angle first. So we know when we add together angle A plus the measure of angle B plus the measure of angle C, we have a triangle. So anytime we add those together, we should get 180 degrees. So then angle A is 33, angle B is 47, so we're just plugging those in. And then we have angle C equals the 180. So we're going to add together the 33 and the 47. So when we add those two together, we get 80 plus the measure of angle C equals 180. So then subtracting 80 from both sides, that'll leave us with angle C. Those cross out, so we're left with the measure of angle C equals 100. Okay, and that's just our angle sum theorem that we had from semester 1. Alright, so then from here, we're going to be setting up, let me go ahead and label that, I apologize. We're going to be setting up our different proportions to find sides A and C. So let me pull up just a little bit here. Alright, so the first one I'm going to do is I'm going to set up B and A. Okay, so I've got sine of B over side B equals sine of A over side A. Okay, I know both parts of B, and I'm missing a piece for the A. So I'm going to set that one up. And then the other one, I'm going to still use B because I know both pieces of those. So again, sine of B over side B. This time I'm looking for side C. So sine of angle C over side C. Okay? We're going to scoot this up just a little bit. So from here, now I have my proportions set up. I'm just going to be plugging in the pieces that I know so that I can solve. Alright, so here's sine B. That's angle B, so that's 47. So sine of 47 over side B is 14 equals sine of angle A, which is 33, over side A, which we don't know, so we're going to leave the A in there. I'm going to do the same thing for this other side, and then I'm just going to work on one to solve, and then I'll come over to the other one. So substituting in sine of angle B, so 47, over side B is 14, equals sine of angle C, which we found to be 100, over side C, which we don't know yet. Okay? Alright, so let's go ahead and slide up here so that way we can start solving. So whenever you have your proportions, the first step to solving those is always doing your cross products. So that's where I'm going to start. So I have 14 sine of 33 equals, the other side is going to be a sine of 47. And you notice I did put those in parentheses because sine and the 33 go together, so we want to make sure that those stay together. So then from here I'm still trying to solve a, so I want to get it by itself. I have this other term with it, sine of 47, so I'm just going to divide by sine of 47 on both sides. Okay, so I'm left with 14 sine of 33 divided by sine of 47 equals a. So then when we punch that into the calculator, it tells us that we're going to be rounding the sides to the nearest tenth. So I'm going to round that, and I get approximately 10 and 4/10, or 10.4. Okay? So when you punch that in the calculator, it's really important to make sure that you keep the 14 sine of 33 as the numerator and sine of 47 as your denominator. Alright, so let's go to the other side. Here, again, our cross products. So we have 14 sine of 100 equals c sine of 47. Okay? So then again, I have to divide by this extra piece, so sine of 47 on both sides. So we have 14 sine of 100 divided by sine of 47 equals c. And again, we're going to be approximating that to the nearest tenth, so we type it into the calculator, and you should get 18 and 9/10, or 18.9. Okay? Alright, let's do one more example here. This one's a word problem. So when the angle of elevation to the sun is 62 degrees, a telephone pole tilted at an angle of 7 degrees from the vertical casts a shadow of 30 feet long on the ground. So we're going to find the length of the telephone pole to the nearest tenth of a foot. So what we have going on here is we have a nice right triangle that's going up to the sun. Okay? And then we have this telephone pole Okay, so we have a pole. So I'm going to put an arrow there. This is our pole. And it's leaning. Okay, and it's leaning at an angle of 7 degrees. It says a telephone pole tilted at an angle of 7 degrees from the vertical. Okay. So that is here, 7 degrees. And then we want to find the telephone pole's length. So that's the piece we're looking for. It also told us we have a 30-foot shadow. So we're going to put that down here. This is our shadow coming out. And let's see, we also had 62 degrees here. Okay. We know that this is originally a right angle. So we can find some other angles there. So we have our picture. We know that these are perpendicular to each other, so that's going to help us. So then we have, we're subtracting, let me see here, let me go ahead and label these pieces. This is G, D, P, so it makes it easier to talk about here. And this is our sun. So to find this angle, we're going to take 90 minus the 7, which is 83. So this is an 83 degree angle. Oh, I apologize, you can't see my work there. So I just took 90 minus 7 equals the 83, so that's how we get this. This is a right angle, which is 90. We said this was 7, so we're just subtracting those. Okay? So then from there, we know that this triangle if we add all of these together, we should get 180. So 62 plus the 83 plus, we're going to call it GPD. GPD equals 180. So then we add those together. 80 plus 60 is 140. So 145 plus angle GPD equals 180. So we're going to subtract that 145 from both sides. So angle GPD equals 35. So this is 35 degrees. Okay. Since we know the measure of the two angles of the triangle, then we can find that GPD and GDP. So in the length of the opposite side of one of the angles, GD, we can use our law of sines to find the length of the pole. So we have this one goes with this one goes with this one. Okay, so sine of P over 30 equals sine of G over, we'll do that lowercase g because that's our pole. Okay? Alright, so then from here, we're going to be plugging some things in. Sine of P. What is angle P? It's 35. So sine of 35 over 30 equals sine of G. G is 62 over lowercase g. So then our next piece is cross products. So we have 30 sine of 62 equals G sine of 35, parentheses there. So then we're dividing by sine of 35 on both sides. And let's see, it says to the nearest tenth of a foot. So in order to find this one, we're going to be rounding. So we just take this piece and round it. So we get G is approximately 46.2. So the pole is approximately 40, I apologize, I said 46, but I wrote 42. 46.2, so 46.2 feet tall. And that's our final answer there. That's all I have for today. Have a great evening, and I will see you in class tomorrow.